Earthships.com, Green Building Sessions. This is a bonus session on Earthships. And this is actually part 2 of Earthships. We did a little drill last time, a little pop quiz on drawing a home. Earthship sketch. Well, we got part 2 here today. Tonight, tomorrow, whenever you happen to be watching this webinar. Everything you ever wanted to know about Earthships but were afraid to ask. We started out last week with this photo of Happy Castle, which is the name of this Earthship. And we're looking at the north side. You can see we have a vermin behind it, so obviously both sides are protected and very well insulated from the earth. These people decided they wanted a north entrance for some reason, but this one's very, very beautiful, very artistic, as you can see. A lot of thought was put into this one. The overview for this session, last week we got through construction, and this week we're going to do the 6 pillars of Earthship design. We're also going to talk about what we can learn, and I'm going to go through a bunch of resources, and we have a bunch more on the webpage as well, but I also have more construction stuff too that I'm going to loop in down here, so got a full slate for you. So without further ado, let's get going. This is the Phoenix rising above the Taos High Desert. Very beautiful and kind of a super Earthship that I believe Michael Reynolds built this sort of as a showcase. This is the Greater World Earthship community. Over here you can see the visitor center and the offices closest to me. Apparently this used to be a industrial site here that they've reclaimed. You can see that's the new educational center they're building. And I think it's 500 or 600 acres here. You can see, oh, I don't know, there's, see that one glinting in the distance, the greenhouse glass. But there got to be at least, I don't know, 30 Earthships on this community already, and several under construction, several for sale too. In the distance you can see Taos. Beautiful mountain range. Okay, so the 6 pillars of Earthship design. Well, Michael Reynolds explains this a little bit differently. I like the idea of pillars. Obviously, it's reference to buildings, and these are some of the key concepts that we can learn about the design principles of the Earthship. But before we go there, I want to take a minute to talk about this building, Villa Savoie. If I'm pronouncing that right, I don't have much French, but this was designed by Le Corbusier. Le Corbusier, the famous Swiss architect. This was built in 1929. He's sort of a father of modernism. He coined the phrase a machine for living, and this was the building that was the machine for living. Very interesting. So 1929 is before World War II, not long after plumbing and electricity were first being put into buildings. And this was a radical building at the time. A complete departure from conventional design and adornment. But he came up with and became famous for 5 points of what made a building modern. And the reason I'm bringing this up is because I like the term machine for living, and I think Earthships fit into that. And in a very different way than this did. But he was very interested. This was the age of industrialism, and his 5 points included, number one, that you would lift the building up off the ground using a series of pylons. You can see them here. This would set the building free from the surface. He also believed that you should build the building so that the structure, you didn't have to have any interior bearing walls, so you could have a very free form floor plan. He also believed that you should have unencumbered views, and this was also through the structure. These horizontal windows gave you unencumbered views to the outside, and obviously there are no requirements for heavy beams coming through here because he's sliced this entire building. Well, you can actually see the beams that, or the posts that do come up, are the posts that support the whole building. He believed that the facade should also be free to be treated in different ways. Remember, this is the time when they had buildings with lots of adornment, they were still kind of clinging to Greek pedestals and very formal designs with Greek reference to them. And then he also believed that on the top you should have a garden. So this area up top here is actually a garden area, and he believed that by putting a garden here, you replaced what you took away by building underneath. So those are the 5 points of the guy who coined the phrase machine for living. Now we move forward to the 21st century, to the Earthship and Michael Reynolds. The 6 pillars of Earthships are, number one, to use salvaged or recycled materials, to create your own energy, capture rainwater. The building should be able to heat and cool itself. It should also be able to treat its own wastewater, and it should grow food. Pretty interesting, I think. I mean, all of these things certainly are quote-unquote green, but in most communities, a quote-unquote green building doesn't go this far. I mean, now a lot of people talk about growing food, but in our modern era, how many of us are really doing that? There are new, a lot of gray water systems are becoming a lot more accepted from the permitting process. The way Earthships are built compared to typical houses is a far cry in the heating and cooling of itself. There's a huge difference. We're going to go through each one of these points in depth. So let's get right into it. The first point, recycled materials. It's really more than tires, but tires is the signature of the Earthship. And through all the stuff that I've read and all the videos that I've looked at, I haven't found out what his original inspiration was for the tire. But tires, and not only do his buildings use tires, but they use lots of other waste products, including cans and bottles and waste wood. And there's an interesting film called The Garbage Warrior that you can get at Earthship.com that talks a little bit about some of his philosophy. And he's now building buildings all over the world, and tires are, the funny thing about tires is, they're kind of dirty, smelly. You really probably wouldn't want to pick one up with your bare hands that much because they're all black, and they've got all different shapes. Some have white walls, some have big treads. I suppose they're not really sexy, so to speak. And Michael Reynolds himself says he'd use something else if he could find something that was better, but he just hasn't. And the tire is, the way he's used the tire is really pretty amazing. We talked about how, when you build these buildings, you compact the tires, you ram earth into the tires. But I did a little research on tires as a waste product, and you can obviously get tires anywhere in the world. These last 2 photos are tire recycling plants in Colorado, which apparently is one of the states that has the most tires in the United States. And I think 80% of all used tires are in sort of 11 states now. So they're starting to try to find uses, and supposedly 80% are reused, but apparently we use 250 million tires a year. Phenomenal amount of tires. And what the tires are being used for now, typically in terms of recycling, are the number one use is burning tires for power. There's a lot of embodied energy in a tire, and it can be burned, but I am sure that the off-gassing is horrible, and I don't know much about the plants that burn these things, but you would think that it's kind of an iffy way to reuse tires in terms of the environment anyhow. Second largest use for them in recycling is to grind them up, and they grind them up in little chunks and add them into other products such as roadways. So they actually put rubber into tar roadways. And then of course you've probably seen recycled sandals, and if you're interested you can Google this address here. This is in Colorado. It's called Front Range Tire Recycling. It's just kind of interesting. You can see the satellite photo, a massive tire recycling plant. So the point is, we got a lot of tires and there's not much else good to do with them, and Michael's figured out a way to employ them in the construction methods of Earthships, which we discussed last time. Because they're thick, they're approximately 3 feet wide, it gives you a very wide wall, and once they're compacted or rammed with earth, you've got a massive mass. As you can see, this here is actually the back of an Earthship. Then when you're backfilling the entire Earthship with more earth, again, when we compare a 2x4 wall, which is almost 6 inches by the time you put siding and drywall on it, compared to a Earthship wall, which is 3 feet wide, plus another 4 or 5 or 6 feet of soil, just think of the insulating capabilities of this huge mass versus this, and we're going to talk about that some more too. But this is on site at the Greater Earthship community. There's lots of piles of tires. I don't know where they get them, but I'm sure they're hauling them off from whatever landfills there are around, so that the landfills don't have to truck them off. And I've heard that some people actually get paid to remove tires, so not only are they they're better than free. Also, when you travel around the Greater Earthship community, you can see various projects in various degrees of construction, and here is some of the other waste product that's being used. You can see all these bottles that they've got here. They make bottle and can walls, a bunch of different wood type products. Those are old, what do you call those things? For some reason they never seem to want to recycle these things, but they're the pallets that material comes on. I know an artist in New York who just used to use pallet wood to create his art. But a key concept, and one of the pillars of Earthships, is to reuse materials, and this has been particularly successful in disaster areas or lower or developing countries where people can have access to these materials for free, and they can use them themselves to build their own homes. And this is again what a tire wall looks like. You can see these tires have been stacked up. You can see they alternate, and they've been rammed with earth, and you can see these are some of the lath wire that's going on there to fill gaps where the tires didn't quite match together. They've started filling this wall with mud and cans and concrete to build out a smooth face where they will eventually stucco this, and it'll turn into a nice stucco wall. Just a little detail on that, you can see this one has bottles in here. Sometimes they use bottles, sometimes they use cans, and they also sling mud, sort of they create an earthen, like adobe mud, in to fill all these voids, and then they'll eventually nail on the wire lath for the stucco. Again, we talked about this last time, but the method for building walls out of these tires is very simple. You place them on the ground, you start filling them up with some of your excavation fill, and start slamming the dirt into these tires. which creates these tires, which stretches them, compresses them, and then each row you alternate the tires as they go up. Talk about hard work. Okay, I wanted to show you here actually another way in which recycled materials are used, which is actually recycled land. This development, or this 500 or 600 acre parcel that the greater Earthship community is on, is an old industrial piece of land. You can see a part of it is actually a gravel pit, and they're now turned into housing sites. This is part of the old, looks like a gravel mining pit that they've now reclaimed and started to build Earthships in. You can see various Earthships there in different stages of construction. Looking at the back side of them. So a lot of green building programs like LEED and others will give you extra points for using brownfields or restoring land, or taking land that has been damaged and using it. So not only are they using recycled materials, but they're using recycled land here. Pillar number 2, create energy. Each Earthship, these are all off the grid, each Earthship is creating all of its own energy. A typical solar electric system that we see in most urban, suburban areas is what's called a grid tie system. Very easy to put in. You put your solar panels up here, and you're still attached to the grid, which is symbolized by these telephone poles here. So during the day, when the sun is out and you're generating power, typically a home is not using that much power during the day if everybody's out at work and school and so forth. Excess power that is being created is actually being sent back to the power company, and your meter goes backwards. So you're actually producing power that helps the power company when they supply power to all the businesses which have high demand during the day. And then at night, when everyone comes home and you turn your lights on, your TVs or whatever it is, then your meter starts spinning the other direction. You end up paying the difference. In other words, if you produce, in some states, if you produce more power than you use, you get paid money. In other states, you don't. With a grid tie system, the power that's created by the solar panels is what's called DC, direct current power. And we use AC power. DC power needs to go through an inverter. And that says inverter there, but there's a box there that takes the electrical power and changes it from DC to AC so that you can use it in the house for all your typical electrical uses. Power can be used in DC as well, although you don't typically see it in homes. And this home has no battery. There's no storage. So when the power goes down in the grid, the power goes down in the house. It's simpler, and there's no extra cost for the batteries. Earthships have batteries, and they also use AC and DC power. Just to review, if you've taken the green building sessions, you know all this stuff. This is the pie chart on how we use electrical. There's our heating and cooling, a huge chunk there. It's, I believe, 43%, right? Add on water heating, another 12%. That gives us a total of 55%. More than half of our power, right? Well, think about it. Earthships, you'll see in one of our next pillars, they don't use power for space heating or cooling. They create that themselves. They also use solar water. So right away, they also have a lot of daylighting, and we'll go through some of this other stuff. But right away, they've taken off more than half of their power requirements. In addition, they try to lower their power requirements so that they don't need a whole lot. And many of these Earthships don't have a whole lot of solar panels. You can see these are actually fairly small panels. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is the studio that I stayed in. It's actually 2 units. So it looks like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 on each side. And these actually are on a hinge here, so they can be tilted a little bit flatter for the summertime when the sun is high, and then they can come back down to this 60 degree, which is the optimum level when the sun is low in the wintertime, so they get the most, they create the most energy possible. Again, you can see here is the solar hot water heater, so that cost is taken care of. And remember, there are no power company hookups at this site. So if they don't create enough power, I guess they're using candles. This here is an articulating solar panel. You can see this has 8 panels. Again, they're the smaller size panels on a rig that actually rotates. This thing will track and follow the sun in the sky. I saw several of these that didn't seem to appear to be working, and I think, although it's a good idea, the system I just showed you, particularly where you can just change the angle by simply moving them off of a hinge, might be a little bit better in the long run than these articulating panels. But you'll see a variety of different systems. Also, you'll see some wind energy, some wind power. And then an interesting thing about wind power is if it's windy, it can work all through the night, versus obviously solar electric photovoltaic panels only work when the sun is out. Now this area, Taos, has something like 320 days a year of sun, so they got plenty of sun, and they've also got quite a bit of wind. And I'm going to put a link for a wind power company that I found that looks interesting to me on the web page. But generally, when you have a wind generator, a little turbine unit like this, you want to get it up as high as possible, because that's where the cleaner air is blowing. And I know they've had some success and some not so successful systems that they've used with wind power. But Michael Reynolds has built some very unique and interesting, not windmill type systems, but he built this one building, and I forget what it's called, but on top of the building he had this big cylindrical system. It was a piece of metal drum that had kind of a couple parts, and apparently it was extremely successful and much simpler than the propeller type systems. But most people just use the photovoltaic panels, and this is what it looks like on the inside of an Earthship. You have 2 panels. You can see here, this is a 120 volt AC, and this is 12 volt DC. There's the DC right there. There's the AC. And DC power is different than AC power in a lot of ways. It's typically a little bit more sluggish, but by using DC power, you avoid running your power through the inverter, which typically has some loss of power. Also, inverters are quite expensive, so they handle power in the Earthships a couple ways. They use DC as much as they can. They use it mainly for lighting, I believe, and you'll see some DC outlets. And then they use 120 for things like computers or any other type of typical plug-in power that you might need. So you'll see pretty much all the Earthships with this main panel. There's a disconnect here, as you can see. The solar power is coming in. There's no grid tie system. The power is being stored in batteries, and then it's being sent out in 2 different ways to both the DC or the AC side of the system. And that's a little picture. This is actually in the studio. You can see this is the typical AC outlet that everybody's familiar with in the United States, with the little ground plug there. And this is for DC power. You can see how the prongs are set differently here. Kind of looks like I don't know, the sleepy face and the happy face or something. But this is typically what you'll see inside an Earthship. Here's another system. Looks like this is the disconnect and this is the inverter. And the Earthship people will sell you they have all kinds of power modules and water modules and systems that they've set up, and you can purchase these things directly from them if you like, and we'll give you, of course, the sources for that. This is a Sunfrost refrigerator. I've talked about these a bit in the past, and I'm not sure if this is, I think you can get these as propane refrigerators. You may even be able to get these to run off of DC power. But you can see, number one, it's a small refrigerator. Number two, it is highly insulated. Look at the thickness of this door. So these are super efficient. They require very little power. So part of the philosophy of the Earthship is to make, is to be as efficient as you can with your usage of power. And of course, to be in the modern world, everybody has, or most people seem to have, satellite TV. You can see the DirecTV logo there, and I think this is this is for the internet service, I believe. But pretty much everybody here has internet, high-speed internet via satellite, and also DirecTV if they want television. But I think they're kind of cool. You can see all these sort of like little turrets, and kind of gives it this futuristic look. I think that is that a high def antenna? I'm not quite sure, but you can see this guy has different antennas here he's got an articulating power, articulating solar panel rack here. He's got a wind generator. You can see he's got a couple of satellite dishes. Sort of lends to the look of the Earthship and its possible ability to take off into space one day. Again, we've got TV satellite, and I believe that's an internet. It's an Earthship. Again, we're looking at the north side, which is bermed, obviously. And again, you have these interesting shapes. This one has the two domes and the interesting curving wall. Is probably two fireplaces in this unit, maybe one in each dome. Obviously a little wind generator there, and probably the solar panels are across the front of the building. And you do occasionally see propane tanks, and I know some people use them for stoves. Some people may even use them for heaters as well. I guess you could use it for anything you want. Propane is pretty easy to deal with because you can get a tank like this and store it on your property. You don't need to have a gas line at your house. Some use the propane and some don't. Okay, pillar number 3 is capturing water. So once again, there are no water lines. There's no water system out there. And luckily, in this area of the country, they seem to get water on a fairly regular basis, at least compared to where I live. I'm not sure what the rainfall totals are there. I'm guessing somewhere around 25 to 35 inches a year. But this again is the studio that I stayed in, and so the entrance, you can see these are the tire walls. We're looking at it from the roof of the Earthship, and the entrance is down here. And these are the tire walls that continue around. And this cistern is built here in the berm. And even the roof of this cistern drains into the cistern itself. And this is part of the rest of the roof, which also comes down to the cistern. They use a lot of this EDPM. This is rubber roofing. And I think he's making a move towards trying to use more metal roofing, which is kind of nice for water collection because it's very clean. And the rubber roofing, I don't really believe it's, well, there are different types, but a lot of it is not meant to be left exposed. You can see that he's using a light color here so that it doesn't absorb a lot of heat. I'm not quite sure why this one is darker. There's a skylight, or a little venting light. And again, the top of the solar hot water heater right there. This is a cistern which is in the visitor center. You can see they have kind of a self-guided tour, and you can walk around. That's what that number 5 is for, and a little explanation here. But this holds water caught off the roof, and I believe some of the units actually have cisterns inside like this, which are open, but more typically they are now using the plastic type of cisterns that you purchase and putting those into the berms in the hill versus making their own cistern. You can see that when you make your own cistern, you have to coat it. You can see how some of the paint or whatever the sealant is chipping away there. And I think they've found that it's really just simpler to go with the plastic cisterns, the kinds that you can purchase. Also, they can be buried into the ground, into the berm, which is a good spot for them. Okay, so passive heating and cooling. This is a little diagram that we used last time talking about the construction. If you recall, this would have been the original grade, and the Earthship is cut out. Part of it's down in the earth, so you're walking down in this area. Your envelope for living is right in here, and this continues to get bermed up with earth. So we talked about the optimum degree of the sun, wintertime and summertime. This would be the 60-degree angle, which is optimum for that area in Taos. And that winter sun is going to penetrate right into the building versus the summer sun, which is going to be cut off because the summer sun is high. So it's going to be shadow because the glass face is just out here. So look at what happens when this penetrates. When the sun penetrates, it heats up the floor, heats up all these massive thick tire walls, start to have this very large mass of ground, tire and everything else, that's all heated up and warmed up. And that's sort of like a battery, actually. It's kind of like the solar system as well. The energy gets stored in this area that's close to the area that's getting heated up, this big mass of earth. And everything below, I think it's below 4 feet. If you dig a hole 4 feet in the ground, you have a pretty constant temperature of somewhere between 55 and 60 degrees. So since we're all bermed in here, you can see most of the building is insulated by that thick mass, which is going to keep it 55 to 60, which worked out pretty well in the wintertime when it's 30 below, and pretty well in the summertime when it's 100. And in between, you can also control how much sun comes in or doesn't come in by using blinds in the summertime to keep it a little bit cooler. But another innovative approach that I really like that Michael Reynolds has done is he's added tubes which come through again, here's our massive earth and back here. He puts tubes that travel through the soil it's being backfilled. And in the summertime, since this is 55, 60 degrees back here, the air that's coming through these tubes actually gets cooled and comes into the unit. So he has a natural air conditioning. And this particular model that I showed you was one of the U-shaped models, one of the earlier shape Earthships. And they now have, I'm going to show you some information about the global plan, which is a little bit newer. But they now have, and it's more expensive, but it's a more efficient method of working with the Earthship, which is actually two greenhouses, or two greenhouses. You have your exterior layer here, and then you have another set of windows here. So you have a much more controllable airspace, which you can either let in or keep out, depending on the weather. And in combination with drawing air through the building, you can actually draw cool air in and cool these buildings. One of the problems we have with radiant heat, which is such a terrific way of heating buildings, running the tubes through a slab, is that it's much more of a challenge to cool those tubes in the floor, which doesn't work quite as well because as the heat warms the air above the floor, that heat rises, whereas if you cool those floors, it doesn't rise. And there's also some issues with dew point and moisture. But this idea, I think, is fabulous, of just bringing the air through the earth to cool it off. And back to the whole idea of a machine for living, I think an Earthship is definitely a building that you actively live in. In other words, you're not just hitting the thermostat. You're opening some windows. Skylights we didn't talk about either, but typically in these older units they have skylights back here, which are ventilation. So you open this up and it draws the air up and out. In the global unit, they control the air more up front here, and they actually have skylights in the summertime. This air will move out of there, or they can actually use this air drawing out to bring the cool air in. But as a machine for living, you're active here. You're opening and closing windows. You're working with the building to make it work for you rather than turning on a switch. Okay, so just a shot here. This is a building just showing you the backside. You can see here's the tire walls, which are 3 feet thick. And then look at the berming here all the way around the back. This, I think, is a particularly nice looking Earthship here. Again, it's got 2 domes. You can see there are 2 skylight units up there that they can use for ventilation on top of the domes. And here are the tire walls, and look at how thick that berming is. I love the green color, the green sagey color. Oh, also let's just point out, well, you can see the solar panels here. They have some ventilating windows up front here. As I mentioned, there's all, everybody sort of takes some artistic license and does their Earthship a little bit differently. Here's another unit that's actually built up into a hillside. This is in the gravel pit, and I'm going to show you some more on that. But you can see 1, 2, 3, 4, 5, only 6 solar panels up there. A typical home around LA, it wouldn't be uncommon to have 20, 30. I recently was watching some video on a guy who had a quote-unquote green home, and he had 85 solar panels, photovoltaic panels on his roof. So it's a massive difference in electrical consumption, and that's really a way of living. If you're going to heat and cool your building with giant air conditioners, you're going to need a lot more power. This is in the studio, and it's just a little flap window, or not even a window, but it's just a ventilation flap. You lower this and you open the skylight in the back of the building, and the cool air draws right across, or whatever the air temperature is outside, creates a little thermal convection loop, comes through here and up and out the skylight in the back. You can really air out the unit quite easily. And that would be the skylight in the back of the unit. This here is the rope that you pull down and lock on this cam cleat there, kind of like a sailboat. So here's a little tour of the studio again. It's morning here in the Earthship. There's a little tour. We can. This room is U-shaped, about 18 feet wide by 18 feet deep. This is one of his earlier designs. You can see in the back here is a skylight, and this draws the air through it to keep it cool. Obviously internet and computer were an afterthought because these are the cables here. But he's got a pulley system here on a cantilevered skylight, so you can open and close it with this rope here. You can see all the electric outlets. There's AC and DC. That DC is the one with the weird looking prongs that go horizontal instead of vertical. There's a little Kiva type fireplace. And the ceiling has kind of a burlappy material on it in between those vigas, stained a green. Everything's kind of a green washy, very handmade. You can see there's paintings, very artistic. Cloud, like very rounded plaster. This is all a mud, earth, and plaster. This is a, you can see everywhere where there's a shape. You can see how this contour follows the shape of a tire. So we got the U shape coming back in. Natural light obviously up front. This is the little bathroom area. And the toilet works off of gray water. So the water you use for showers and the sink goes through the planter and then comes into the toilet. There's the sink. You can see the regular water and the drinking water separate drinking water faucet. Tub. All these skylights are custom made with big pieces of insulated glass. Okay, I just wanted to show you, this is what they call the global plan, and it's one of the more modern evolutions of the Earthship. This is actually the educational center, and this is right where you drive into the visitor center, which is on this side, and this is the educational center. Really beautiful building. They're still working on it. You can see the outside area here is actually designed for food production, and if you look in here you can see there are 2 greenhouses. So let's take a look inside. Obviously used for display and education and so forth. They have a lot of these signs hanging down here about their work. I think these are actually now LED lights that they're using. You can see the beautiful vigas and the nice earthen plaster they use. I believe this is also an earthen clay floor. Really pretty. And this is the double greenhouse that I was talking about. You can see, actually they've got quite nice shades that they use to control the light and heat that's coming in. They also have, these are Velux windows like the skylights, and they have windows on top so they can create, they can cool this area down in the summertime when it's 110 degrees out. It doesn't need a lot of heat gain, obviously. They've got a greenhouse out here with big planter. This is very pretty red stone, flagstone. And then they have this second layer here, so they can actually pull hot air in or keep hot air out by having these 2 layers. Again, there's the outside layer with the optimum sun angle of 60 degrees for that Taos winter sun. And here's the inside. You can see a second planter inside. Obviously a lot of natural light comes in, winter or summer. But in the wintertime, that sun's going to come way back in here and it's going to heat this darkly colored floor. Here's the outside of what we just looked at. You can see these Velux units. So they've got it, again, this was probably 110 degrees outside, so you can see they've got everything opened up so that the air is circulating up and out. These are cantilevered, counterbalanced skylights. There's actually a little weight in here, and they put these on a hinge, so they're very easy to open from the inside. Which takes us to number 5, wastewater. Michael Reynolds says and does use water 4 times for his buildings. And in America here, we use lots of fresh water for everything and then push it down the municipal sewer lines like we've talked about many times. But in an Earthship, you use it 4 times. First of all, you capture water and you use it as fresh water. So the water you capture is what you use to drink. They have purification systems for the drinking water. It's also what you use in the sink and in the shower and so forth. So that's use number 1. Then after you've used the water that time, it then goes into the planter beds as gray water. And the planters actually treat the water through the natural process of the plants and also sort of filtration systems through rocks. I'll show you a little detail on this. And that gray water then is pumped into the toilets. So the fresh water is going to the planter, and then the planter water is being pumped into the toilets. So you're using gray water for your toilets rather than fresh water. And then the sewage or the black water is being pumped out to typical leach fields, which then in turn nourish the plants outside as that water is treated through the process, its natural process in the septic tanks and leach fields. Michael's also done some interesting stuff with solar septic systems, and I don't think he uses them too much because there were some challenges with them, but very interesting. They actually incinerated waste using solar septic systems, which is quite a good way to do it. But I wanted to just show you here. Here's your Earthship. Typically there is a planter dug here next to the glass, the greenhouse glass on the south side, right? And what happens is if we look at this, if we looked at this from the front, so we had our planter coming across the front, and above here is our greenhouse glass. So we're looking at the building from the south, or kind of looking through the building. You'd have your greenhouse glass, your plants growing up here. What they do is they dig this out. They use a membrane and create sort of a pond. They fill up the bottom with big rock, and then they use some filtration membrane, or they use smaller rock and then sand, and then they create their soil bed here to grow the plants in. And then so the water's being pumped in here, the gray water's being pumped in here and used by the plants. Plants are growing. Sometimes they're food plants. They have all different kinds of things that you can grow in there. And the water is being treated by photosynthesis and all the biological ways that plants use water. And then the excess water is also being treated by being filtered through these rocks. And then lastly, there's I believe a peat filter down here, and then another sort of lower area here, rock filter, where the water is collected and then pumped back up for use in the toilets. Pretty innovative. You might have trouble doing that in Ventura County in California or some other places around the country, but it's working great for them and a really good way to be efficient with water usage. Okay, so here you can see, I think they've actually typically now they take the sink water and put that into the septic system because of issues with grease and food particles. There's too much, and we advocate that too. Unless you're diligent about composting and keeping food particles out of the water, it puts a lot of extra biological stuff into the gray water that you don't need. So the sink may or may not go to the gray water, and you can see in this case here's the kitchen, and you have your regular faucet and your extra filtered drinking water, and then the gray water may or may not go directly into the planter from there, but certainly all the shower water and the other sink water goes in there. It's just some of the cabinetry under the sink there that they use some interesting materials. Within this is the underneath the sink. Probably looks a lot more complicated than your system at home. And I think part of this is actually due to the fact that they have all these different shutoffs so that they can prove to their building inspectors that they don't need to use the gray water, that they can send it all to the septic system. Kind of a crazy thing. But they probably do a little bit more extra plumbing. And if you want to set up a separate set of pipes for a gray water system in your house, you're going to have two sets of pipes too. Okay, this takes us to our final number 6 pillar, which is to grow food. I showed you in the beginning of the first Earthship webinar the Phoenix right here, and I showed you the floor plan I think, I'm actually not sure, but I think this is some kind of a solar oven or solar septic system going on here. But this whole area outside here is created for food growth. Now the Phoenix, if you recall, has not only food growing inside and a couple layers of greenhouses separating the building, but they've got an exterior greenhouse. They've got planters in the exterior greenhouse. They've got planters on the interior greenhouse. They also have a tilapia fish pond inside there. So they've got fish, they've got vegetables, and then they've got this entire outside area which also is nourished through the septic system as well. I know that sounds a little bit ridiculous, but these would be different kinds of plants out here, but can also be nourished by the septic system. Okay, so there's again the global Earthship, the educational center. Okay, so those are our 6 pillars. I just wanted to take you through a little bit more on the construction side of the Earthships, some stuff I didn't get to show you last time. Here is a Earthship in the greater Earthship community, global Earthship community, that is under construction, obviously. And I wanted to show you a couple things. Obviously, this is the tire wall. You can see it's packed out with its mortar. They're getting ready to make it nice and smooth so they can stucco it. You can see some can walls here that are coming out from the tire walls. This is an entrance, and you can again see your 60-degree greenhouse wall. On this particular Earthship, the part that comes up out of the ground, they've heavily insulated it with probably EPS foam here. There's a detail you can see a little bit better. You can see there's some rocks being filled in on the exterior. They have bottle walls and can walls. They're starting to put on the metal lath here so they can stucco it. You can see a bunch of bottles are about to use for construction. And I wanted to take you here. This is a little tiny building that was right near the studio. It's actually a chicken coop, but I just thought it'd be interesting to show you a mini version of construction. Here's a little structure under construction at the Greater World Earthship community. I think this is a chicken coop. You can see scattered around here. Tons of cans and bottles. Not the neatest job site in the world, but let's see what we can find out. You can see how they stack the tires and they fill all the gaps with cans and mortar all around it. This has both traditional log type vigas and dimensional framing. Doesn't seem to be catching water like the other Earthships, but I think it's just kind of a little utility building. You can see these tires here. It's kind of interesting the way they set them up on the dirt here, because it spreads the weight out. It makes a very effective footing. And these things, if you kick them, they're like iron. They don't flex at all. Just because they're tires, don't think they flex. Okay, this is the visitor center, or part of the continuing experiments that are going on at the visitor center, continuing construction. I believe he has, and when they do the internships, they kind of build these little by little. But I wanted to show you these because these are dome structures. We didn't talk too much about domes. I think some of this is prototypes for what they're doing in some disaster area where they found that the dome structures seem to work quite well. Again, you can see the modern world up there, but this is all glass bottles throughout here, and what they'll do here is they will put the can walls up on top, particularly where they have a bond beam. There's a little round window and another can wall. Kind of pretty when you look at them that way, I think. And I think I wanted to show you with the can walls, what they do is, let's say this is the top of your tire wall, right? They will build a can wall on top, which has a layer of cans out here, some concrete mud, and actually the can would be kinked, right? So the mud comes in here. The next can comes on top, and it's kinked, partly crushed. That helps make a place for the mortar. And then they will do another can wall over here, kinked can. My kinked cans aren't very good. There we go. And then they will fill this part right here with solid mortar. And this, when you have your tires around in a ring or a circle, almost like an igloo or something, you'll create this bond beam which runs all the way around here, and then that holds that ring gives it some structural integrity, holds everything together, and also is the platform for putting the rebar cage on top. And I'll erase this. We'll look at, let's see, we have our tire walls coming up, and then we've created our can wall with our bond beam. Cans. So this would be like we're cutting through the building, so we would have on two sides the tire wall and the can wall. On the top of a dome, you will build a rebar cage. So rebar is the reinforcing steel, and you'll build a dome of this metal steel with a ring coming all the way around it. And the rebar will be coming up and down, and then they will attach wire lath onto that and eventually concrete it. You may even have a double cage, which can allow for some insulation in between the two. And I wanted to briefly show you that, so that when you look at these pictures of the domes, you can see we're going to go right inside this dome right here. Here's the tire walls coming around it. This is a group of different structures kind of pushed together, but this one right here is a little dome, and on the inside here you can see this is carved. These are the earthen walls right here. So this one has no tires below here. There's the can wall, which has that concrete bond beam, and then that rebar cage, which is up on top. It's kind of pretty looking. And that's again the top of this dome. I'm not quite sure what the purpose of this particular building was, but they had some, I think it was partly, as I said, for research on their disaster stuff, because what they'll do is they'll create these little domes with a water catchment area underneath and a living area up above. I think in Honduras there's an interesting video, and I will put that video link on our webpage. It's on YouTube, and you can see what they did down there. They also have some videos that you can purchase about that as well at Earthship.com. So what can we learn? I think for me this has been a fascinating journey through the Earthships. I'm really glad I went and spent some time there and learned more about what they're all about. And there's some positives and some negatives too, I think, that we can take away from this. But certainly the 6 pillars of Earthship teach us a lot. I mean, obviously anybody who's interested in a green building, if you can incorporate recycled materials, that's very important. You may not be able to use tire walls in the same way an Earthship does, or you may not even want to, but maybe you could use those for landscape walls. Or maybe you could think of using recycled materials in other ways. Obviously, creating energy is a huge part of a green building. which we can do easily with grid tie systems, or if you want to go further, you can do a battery system, or you can do something more like they've done in the Earthships here. Collecting rainwater. This is something that, Michael Reynolds has been doing this for 40 years, and they've been living off the grid there. A lot of people think water is the next oil, and there's some frightening statistics about water. And you can see more about that in the 50 Green blog if you want to look it up. But in my little town, our water system, as I've mentioned many times before, I think the water prices have tripled over the last 3 years, and they're probably not going to stop there. So water is becoming more and more of a scarce resource. So I think it's always important to include some way of thinking how you might capture and use rainwater in your project. Obviously, heating and cooling, we know that that's almost half the energy that's required for a home. So I was fascinated by the way they use the mass and the thermal mass as a battery for heating and cooling. And I think we can learn a lot from that. And some of these new ways of building, like ICF, insulated concrete forms, kind of go a long way towards reaching better mass that we can use in a building compared to a stick frame building. Treating wastewater, we're starting to see some areas that are allowing gray water systems, and gray water systems is sort of a first step in terms of, and also using water 4 times like they use water. Any way we can conserve water means we're using less water, which means we have to capture less. And obviously, the less that we can send back into the municipal systems means less pollution out in the ocean. Growing food, as we've talked about, is probably the penultimate part of a off-grid survival type of mode in green building. It's if you can live off-grid, capture your own water, and grow your own food, then you're truly your own individual system. I think some of the nuggets, the gold nuggets that we can take away from this, are obviously the mass we've just talked about, the thickness of buildings. So if you're designing a green building, if you're in a really hot area, maybe you're going to build it into a hillside and face the building north. There's a good book that Michael's got where he talks about the Earthships in all different kind of climates, and I'll tell you more about that in a second. So there's a ton to learn there. If you're in a cold area, maybe you want to open your house out up to the south, but you could still tuck part of it into a hillside maybe. Solar, not only the active part of solar panels, solar hot water, but the passive part of solar, figuring out the angle of the sun, is key to any green project. The sun is obviously our biggest source of energy. I think that the whole idea of having a truly independent, Michael Reynolds, I think, would say that this is true freedom if you can live off the grid. Water we talked about. I think another really interesting concept in the Earthship is Michael Reynolds' ability to look at a building truly in terms of how it relates to its environment, rather than trying to take some type of historical architectural style and adapting that to an environment. And of course, some people are not going to want to do this, but I think it's worth thinking about. Think about how you might build your building to work in your particular climate, and how that might create the style, how that might create its own style. I think we need to think about moving away from older style buildings. We don't drive Model T Fords anymore. They say that I think 80% of the housing stock, which in America I believe is 70 million homes, it was built between World War II and 1980, and most of that housing stock is grossly inefficient and could easily be more efficient. But if we start looking at designs now from a new perspective and making them net zero, that's a whole different jump altogether. This map comes off of the Earthship.com website, and they call it pockets of freedom. All the green spots here are areas that they've identified, counties in states where they believe that you can build an Earthship. You can see here's New Mexico. Taos is probably right around here. So Michael Reynolds has done a lot of work in making a lot of New Mexico a pocket of freedom. You can see in Colorado there's a couple of spots here, but there starts to be a lot of red. Wyoming's got some green. My state of California, almost all red. And we are so heavily regulated here, you can't bring any kind of new building product into the realm of permitted building structures without having it licensed and tested, and it's extremely expensive to be a manufacturer of product. Just to test it according to I think it's called ICI, the International Code Institute. And I think Michael's trying to develop this map and trying to push for allowing more experimental, as I know for a fact he's actually had some laws created in the state of New Mexico and for his Earthship communities that allow him to build these experimental buildings, because they feel that, and rightly so, that it's really important that we look at buildings in a new way. As I said, you may not be able to build one in your area. Maybe you just, you can appreciate this, but you don't want to build it. So let's just take, if nothing else, some lessons from the Earthship and apply them towards our buildings. If you really like Earthships, there are all different ways you can get plans and consultation from the Earthship Biotexture office in Taos. And again, we'll give you all the links for that on the webpage. But if you decide to build one of these, make sure you understand what your challenges are in your area. We've talked about the circular vortex of permitting hell, and I think I was looking at one of the videos of Michael Reynolds, and I think it was, he actually went to Copenhagen and spoke there. It might have been that one, but he said he's often being asked by people in different areas like Ventura, California, how can I build they won't let me build an Earthship in my area. What should I do? And Michael's answer is move. So you may want to move to a pocket of freedom before you build an Earthship, or maybe you're up to the challenge of pushing it through your own building department. So this wraps up our Earthship webinar. This is the second one. And Earthship.com, again, I will put this all on the webpage. Earthship.com is Michael Reynolds' site. There's a ton of information on there. He's also got, I think he's written 6 or 7 books. I put a few of my favorites on the webpage that I think would be really good reads for anybody. You can also do internships if you want to go there and get your hands dirty and actually build Earthships. They have various internships. They also have sort of 3-day seminars. You can go there, you can stay there and learn from Michael himself. And if you ever get a chance to get to Taos, I think probably the easiest place to fly into is Albuquerque, which is probably, I'm guessing, a couple hours, maybe 2.5 hours south of Taos. But it's definitely worth popping in there, checking out their visitor center, checking out their educational center. So as usual, any comments about the Earthship webinars, please let us know at 50green50@gmail.com. I'd love to hear from you. What do you think? Do you like Earthships? Do you hate them? Are they beautiful? Are they ugly? Are they crazy? Are they enlightened? Let me know. Send me your comments, and we look forward to seeing you on the next webinar. Once again, this is Otis Bradley signing out. Thank you very much.